Mixtures and physical and chemical change, and we're going to review conservation. He lived in France, so how do you think he died?
Plague.
No.
That'd been a cool death.
Think about some of the... Right, but what was one of the death methods that they invented in France that everybody hated? What?
They ripped him apart.
No, starts with a G.
The gallows.
The guillotine, yes. He got his head chopped off in the guillotine, right, in the French Reign of Terror. He is the father of chemistry. Often you'd be like, man, the father of chemistry, he should have had a nice ending to his life.
Yeah.
Not. Just remember that when you're having a bad day. Just remember the father of chemistry, they weren't very nice to him. Change today. So there are two types of change. I'm going to introduce the second type of change. We talked about one yesterday when we burned the candle. Today, this is the second type of change. So what type of change is this? Raise your hand. If you know what type of change that is. It is a physical change. Very good, Adam. Excellent. So I only remember one. Claire, don't try to remember everything. Just remember the scissors cutting the paper is physical. Why is it physical?
Because it's only changing the physical and not the chemical.
Is it still paper?
Yes.
It's still paper. That's what you have to remember. It's still paper. It's just changed a little bit. It's been cut. If you run over a nail when you're driving down the road, is that a chemical change?
Physical change.
It's a physical change because you still have the tire and you still have the nail. It's just physically changed. All right, so
To be a compound of hydrogen and oxygen.
okay, very good. So what did Antoine Lavoisier discover?
Conservation of matter.
Conservation of matter. He also discovered something with O.
He discovered oxygen.
Yeah, he discovered oxygen, which is really kind of neat.
114.
Because I'll tell you that Lavoisier actually gave oxygen its name, which is really kind of neat. This comic, Chemistry, is a really good resource. What happened to Antoine Lavoisier?
He died.
How did he die?
Does it say it here?
Doesn't say in here if you read it. He lived in France, so how do you think he died?
Plague.
No.
That'd been a cool death.
Think about some of the... Right, but what was one of the death methods that they invented in France that everybody hated? What?
They ripped him apart.
No, starts with a G.
The gallows.
The guillotine, yes. He got his head chopped off in the guillotine, right, in the French Reign of Terror. He is the father of chemistry. Often you'd be like, man, the father of chemistry, he should have had a nice ending to his life.
Yeah.
Not. Just remember that when you're having a bad day. Just remember the father of chemistry, they weren't very nice to him. Okay, so Lavoisier determined that air is a mixture. And we're introducing mixtures today, right? There are two types of mixtures. Raise your hand if you've ever heard of the two types of mixtures. Okay, Mikhail, what are the two types of mixtures?
Same and different. I think it's homo and hetero.
Very good. Homo and hetero. You probably saw that in biology.
Yeah.
Yeah, biology. So up here we just have another example of that. This would be a mixture of a dye or a pigment in water. What type of mixture is this? What type of mixture do you think this is, Alonzo? It's homo. Yeah, homo is always, you see just one thing, right? So you should see just one thing there. This one's a little easier to see. And in this situation, we have basically tap water and deionized water, right? So water is not the same. These are both mixtures because I have a universal indicator in them, but tap water is going to be a mixture. Deionized water is going to be let's see. Raise your hand. Very good. Compound. So this right here is going to be the tap water. It's got like other salts in it, and like Cody said, this right here is going to be your deionized water. So it's going to be a compound. Compounds just are the same substance, whereas mixtures, you have more than one substance. That make sense? Right. Awesome. So mixtures, more than one substance. Now here is an example of the other type of substance that Michaela said. And what was this one? Hetero. Yeah, the best one to remember, I only have one example here for you because you don't really want to get overwhelmed by this. Just keep it simple. This is just oil and water. You can see there are two things in this. All right, keep it simple. Don't get overwhelmed. Yeah, it's just oil and water. Can you see two things there? Yeah, just two things. Okay, there'll be 41,000. You got 4,100. Left off a zero. Yeah, but you need like 3 of them. Yeah, excellent. Because 41 times 1,000 is 41,000. Nice job. Used to identify a substance. Raise your hand. Raise your hand. Garrett? Very good. Physical and chemical properties. Now, this is very important when you start changing substances. So yesterday, we changed a substance. If you remember, we took a candle, right, and we lit a match. So you see, there's a change happening here. Now, is this a physical or chemical change, Cody? How do you know? So, what is always being produced in chemical changes, Eliza? Starts with an N. No. Go and you buy a blank car.
Nissan.
No. Not an old car, but yeah, you're always making new substances. So chemical changes, this is a new substance here. You're making carbon dioxide. Yesterday we showed you that with the carbon dioxide monitor. Remember that? Yeah. Make sense? Carbon dioxide. So new. Mixtures and physical and chemical change, and we're going to review conservation. Why is it important to be able to identify properties of matter? Anybody? Like up here, if you find a new substance, aluminum, it's highly reflective, pure copper. You can scratch it. It's a conductor of heat, copper that is. When you're trying to identify a substance, a property would be like hardness, color, conductivity, malleability. Now, why do we care about that? Why do we need to know what the properties are of a substance? Lily? Yeah, when you start changing them, like yesterday when we lit the candle, right? If you don't know what the original properties are, you're going to be like a little confused when you have new properties. So a chemical change always produces what? New new physical properties. A new substance is going to have a new physical property. So you have to be able to know what physical properties are, or you won't really know whether you got a new substance or not. That's why it's important to pay attention to what properties. What? Why? He got his head cut off because during the... So yes, the mass stayed at... So this is before the reaction, and we have a mass of 135.49. Now during the reaction it should stay the same. In the end, it should still be 135.49. So the Alka-Seltzer tablet has got citric acid and sodium bicarbonate. And we mentioned that citric acid is an acid and sodium bicarbonate is a base. And when you mix the two in water, what do you get? You might know? 5 points? You get the ocean, which is what? Raise your hand. You get salt water. You're close. If you just said salt water, I'd give you the 5. Because the ocean has salt water in it. All acid-base reactions produce salt water. That's the reason why the ocean's salty. You've got, things you burn, goes up in the atmosphere, makes carbonic acid or sulfur, sulfuric acid rains down, reacts with the soil, you get salt. So acid-base reactions produce salt water.
Also formed an ash and removed gas from the air. Then he heated gently the ash, gave back the gas and all the original mercury. A law proposes the experiment is reversible.
Okay, very good. So basically he started with 10 and heated that, then he went to something else, mercury. And let's continue on. In other words, how about Noah? Nice job. You can see the reaction happening there. Now let's take it over to the balance, because it is going on right now. So grab the balloon with the glass and move over to the balance. Yeah, put it right there. So we've got the reaction happening right now. We're at the during, and we have 135.36, which was our original mass, right?
Okay, I did it.
Get it? Action going on. Lavoisier accomplished. Okay, law of conservation of matter. Very good, Kaya. Tamara, what else did he do besides that? He determined that air was a... No. Yeah, he determined air was a mixture of two different gases. And he did that based on the ratios. Because remember, when he did the experiment, the water only filled up a certain part of the container. So he knew that it had to be something else besides oxygen in there. He didn't know what else, but he knew that it was a mixture. So he identified air as a mixture.
That's good. You go like that.